Hi everybody! Today we're going to be looking at linear equations and slope. So we're doing a little bit of review. Let's go ahead and get started. Our goals for today are to remember what the definition of the slope is, to be able to identify slope on a graph and in an equation, and to be able to tell whether a slope is positive, negative, undefined, or zero. Slope is defined as the steepness of a line. We can calculate it by finding the change in y and dividing that by the change in x. We will also call this rise over run. In order to find slope on a graph, we are going to use a strategy of drawing a slope triangle. So the first step is to pick 2 points that intersect with the coordinate grid. So for example, I might choose A and C. The next thing I'm going to do is draw a triangle connecting those points. So now I have segment AB and segment CB. Now I'm looking at triangle ABC. Once we've drawn our slope triangle, now it's time to calculate the slope. Slope is calculated by taking the rise, or the change in our y, dividing it by the change in x. When we look at our formula for slope, that's what that triangle means. When I see the triangle, I think change in. I can see on this graph that the distance between point C and point B represents the change in y. That distance is 3. I can also see that the distance between point A and point B is 4. That's the change in my x. So my slope here is going to be 3 divided by 4. Or 3/4. Let's take a look at an example where our slope triangles were not drawn for us. We're going to need to put those in ourselves. So the very first thing I'm going to do is strategically choose my points to create that slope triangle. I'm looking for a place where our line intersects that coordinate grid, and I don't want a point that's in between places on the coordinate grid. So I've chosen my 2 points and marked them there in green. You can see they line up exactly with the grid. Then I'm going to connect those with a triangle. So I've marked my rise in red and my run there in blue. I can see that the change in y, or that rise, is going to be 4. And I can see the change in x is going to be 3. So my slope, when I divide the rise by the run, is going to be 4/3, or 4/3. We're going to be able to identify positive slope, negative slope, undefined slope, and zero slope. Let's start with positive slope. If my line's slope is positive, that means from left to right, as I look at the graph, my line is slanting up. Take a look at our example here. We've got a line, and that means we're going to need to draw a slope triangle to figure out the slope. So the first thing I'm going to do is strategically pick my points. I've chosen 2 points that intersect exactly with the coordinate grid. I note that my rise is going to be equal to 3, and my run is going to be equal to 2. To calculate the slope, I'm going to divide the rise by the run. So I'm going to divide 3 by 2, and I find that my slope is equal to 3/2. Notice how both the rise and the run are both positive. Now we're looking at an example of negative slope. As I look at the graph from left to right, my line is slanting down. So that means that either the rise or the run is going to be negative when we go ahead and calculate that slope. To find the slope here, the first thing I'm going to do is draw my slope triangle. So I'm going to choose those 2 points, connect them to form a triangle, and then identify the rise and the run. Notice how this time we are actually going down. We're going down 2, which means the rise is -2. We are running to the right, and so that means we have a positive for our change in x. And I set up my equation here, -2 divided by 2, which gives me -1. Now we're going to go ahead and look at a special case for slope which is what happens to slope when we have a horizontal line, or a line where y equals some number. In this case, we're looking at a graph of y equals 3. So I want to find out what happens when I try to identify the change in y and divide that by the change in x. As I'm thinking about what the slope is of this line, I still want to be thinking about my formula for slope, which again is the change in y divided by the change in x. In this case, y is actually not changing at all. Everywhere along that line, y is equal to 3. And so I'm going to write here no change in y. And I'm still going to be dividing that by the change in x because I can see that x changes as I go along that line. So now my equation kind of looks like this. I have 0 change in y divided by the change in x. I know anything divided by 0 is 0. So the slope of a horizontal line has to be 0. The last type of slope we need to consider is an undefined slope, or the slope of a vertical line. We're going to look at why we consider that slope to be undefined when we apply our formula for the change in y over the change in x. In my example here, I have the graph of x equals -2. I can see that y is increasing and decreasing along that line, but x is not changing. X is -2 everywhere along that line. So that means that there is no change in x. We're going to represent no change in x as 0. I can see that y is changing, but x is not. And so when I set up my equation, I write change in y over 0. I can't divide by 0, and so my slope is undefined. The last thing we need to look at today is how to find the slope given a linear equation in the form y equals mx plus b. When I look at a linear equation, y equals mx plus b, I know that m is my slope, b is the y-intercept, or where the line is going to cross the y-axis, and x and y represent a coordinate pair that is on the line. So if I have an x and y pair that make the equation true, that point is on the line. I want you to practice finding the slope in each of these equations. I want you to take 5 seconds, pause the video, try it on your own with as much time as you need, and then we're going to go back through the answers. When I look at my first row, I can see that all of these equations are written in slope-intercept form. That means I can find where m is, and I know that's my slope right away. For the next row, I need to rearrange each of these equations so they're in the form y equals mx plus b. When I'm rearranging these equations, I need to make sure that I have y by itself on one side of the equal sign and everything else on the other, so that I'm in the form y equals mx plus b. Once I've done the same thing to both sides of the equation when I'm rearranging, then I can look for m. For the first problem in the second row, my slope is 3. For the next one, my slope is 2. And for the last problem, my slope is 6. Thank you guys so much for watching this video. Make sure that you keep reaching out with questions, keep submitting all of your work. You're doing an awesome job, and I'm really proud of you. Bye!